between those 2 points would give area A, the green bit. It's slightly different in the case of the cubic. If we integrate between the leftmost point and the rightmost point, we see that there's 2 places that I've shaded in, and that's area A1 and area A2. Area A1 would have a positive area, and that's because it's above the x-axis, whereas area A2 would have a negative area. The negative area, don't be confused by that in the sense that, oh, how can area be negative? It's not, but the reason it's represented as being negative is because it's below the x-axis. What would end up happening is the positive large green area will be slightly reduced by the negatively small yellow area. So you'll get an end result that's slightly smaller than A1. If we were to just take the example of C1 being the opposite way around, you would indeed get the same area but negative. But it's logical to just take the positive of that area because negative area doesn't really make much sense. So we mentioned at the beginning, we're going to be integrating polynomials. And this is a quick rundown on what a polynomial is, those of us who haven't come across it. Well, polynomials are functions of powers of the same variable. So in this case, our variable is always x, and it's very important that the powers that we use are always positive and whole. So I'll go through the 4 examples here. So 2x, a pretty trivial polynomial, even though it's only one term, it still counts as a polynomial. That's because it's x and only x. X is to the power of 1. Similar thing with 4x squared. We have 4 times x to the power of 2. Once again, 2 is a whole number, and it's positive. In the case of the third one, we have x times 3. Once you expand that out, you can get x squared plus 3x. And once again, both those terms depend on x, and each power of x is positive and whole, in this case 2 and 1. The final example, 5x to the 4 plus 6x cubed plus 4x squared plus 6 is once again a polynomial because each term depends on x, and x is raised to a positive power. In this case, we have 4, 3, 2. And in the case of 6, 6 is equivalent to 6 times x to the power of 0, because anything to the power of 0 is just 1. And as a result, it is indeed a polynomial. Moving on to the next section, we're going to be talking about integrating polynomials.
Okay, so now you guys know what a polynomial is. We should try to integrate some of them. So this is the rule for integrating polynomial, written out in both equation form and in word. We'll go for the word form first. So what we do is, if you read this part, you add 1 to the power, and you divide by the new power, which is exactly what we do here. So to start off with, we have a times x to the power of n. What we do first is we add 1 to the power. So this n now becomes n plus 1. And then we divide by the new power. So we have, instead of a, we have a divided by n plus 1. So just try to remember this rule in your head. Add 1 to the power and divide by the new power. And now we're going to do a few examples. So here we see our first example is x squared, quite a simple example. So x squared, there is a hidden 1 in front of it. It's technically 1 times x squared, but usually when there's a 1 in front of a function, we just don't write that at all. But I'm going to write it here just so it's clearer. So first, we have 1, and we add 1 to the power, so the 2 becomes a 3. So now we have x to the power of 3, and then we divide by the new power, which is 3. And so this one has now been divided by 3. So we know that when you integrate it, it becomes a third times x cubed. Now doing the second example, let's just write down the 4 first. Okay, so we have x, we add 1 to the power was 3 before, and now it becomes 4, because 3 plus 1 is 4. We then divide by the new power, which is 4. We know that 4 over 4 is actually just 1, and we know that once a coefficient, the number in front of the x is just 1, then we can just ignore that. So this is actually integrates quite simply to x to the power 4. And in the final example, we'll see that there's actually two terms. This is the first term, and this is the second term. So when there's multiple terms in a polynomial, what you do is you treat each term separately. So during the first term, we have x to the power of 6, because 5 plus 1 is 6, and we divide by the new power, divide by 6. And the second term, minus x to the power of 8, and then divided by 8. We see that we can do some simplification here, because 3 and 6 in the first term actually is both divisible by 3. So we can simplify that down to a half x to the power 6, and the second term, both the denominator and the numerator are divisible by 2. So that becomes 3 over 4 x to the 8. Also, something quick I might want to add is, so you guys probably heard of the plus c. So the plus c is the integration constant, and we're not really going to talk about it in too much detail here, but the point of the plus c is, you know how we mentioned earlier that integration is used to find the area underneath a curve. Well, in order to actually find the area, we need to know where we are starting to integrate from and where we're stopping. Unless we define these 2 points, we don't know the area. So in the case that we don't define those 2 points, we're missing some information. And this missing information is represented by plus c. Okay, so now we're actually going to do an example of a definite integral. So a definite integral is an integral where you're defining the area that you're integrating to see the area underneath the curve. So first of all, just a quick few formalities. So this is an integral sign. So just bear in mind, each time you see this sign, it means that the integral is taking place. And this dx is just a variable that you're going to integrate with respect to. So in all our previous examples, we've been integrating with respect to x, because x is what we've been dealing with. So that's what you need to know for now. So here, this is the function we want to integrate. We want to integrate the function x plus 1 between 1 and 2. So graphically, we represent it like this. So this is actually drawn to scale the curve y equals x plus 1. And since we're integrating between 1 and 2, this is going to be the area under the curve that we will be trying to find out. So we will first find out the area through integration, and then we'll verify that this indeed gives us the area with a simple counting the squares. So going through this quickly. So first of all, we can simplify a bit slightly. We know that because x has nothing at the front, then that just means it's technically just 1 times x. And also because x is by itself, that means it's actually just x to the power 1. In the second case, it's just 1 by itself. So as it says on the notes here, if something is just a number, technically that it means is x to the power 0, because x is not involved at all. So if I just write out a bit fully, x to the power 0. Okay, and now we apply the rule. The rule is add 1 to the power and divide by the new power. And so that's what we do. So in our first term, we have 1x. Okay, it wasn't 1 before on the power, but we add 1 to the power, so that now becomes a 2. And we divide by the new power. So the new coefficient is a half. Moving on to the second term, we add 1 to the power. So the power was 0 before, but now it's going to be 1. And then we divide by a new power, which is 1. And of course, 1 divided by 1 is just 1, and so we don't write that. And x to the power 1 is just x. We keep our limits of 2 and 1 from what we had in the original. And the final step that we do is we substitute each of those 2 values in turn, the 2 limits, 2 and 1, and we find out the difference between them. The difference between them is what's going to give us this area. So we do just that. We use 2 first. So we have a half times 2 to the power 2 plus 2. Notice all I did is I substituted every time there's an x in this equation. I replaced them with a 2. And I take the difference of that with the same thing, except this time I substituted 1 in. As you can see, it's completely identical, these 2 expressions, except that I sort So if I were to work that out, that is a half times 4, because 2 to the power of 2 is 4, plus 2, minus a half times 1, because 1 to the power of 2 is 1, plus 1. And this works out to be 2 plus 2 minus a half times 1, which is 4 minus 3.5, which is 5.5. 5 halves. But this can also be written as 2.5, if that's more familiar to you. And now we're going to count the squares to verify that indeed that is the correct area under the curve. So we know that an area of 1 would just be a 1 by 1 square. So this square we see here, that's the area of 1 by 1 square. What we want to try and find out is the area between 1 and 2. So this. So we see the area will be 1, 2, and we have half of this third square. So we do indeed see that the area underneath the curve is 2 squares and a half, so 2.5 as we work that out through the integration. Of course, this is a really simple example where it's probably much easier to just draw the graph and just cut up the squares. But in general, integration and graphs can be quite complicated. They don't have to be straight lines. They could be, for example, really squiggly curves. And in that case, it will be way easier to work out the area underneath the graph through doing this whole integration process that we have here, rather than slowly counting the squares. And moving on to the final example, where we're going to go through a more complicated one.
So in this case, we're going to be covering a quadratic. The quadratic of choice is squared minus 5x plus 6. I usually like to draw my graphs first, if I can, and just to get a image of what I'm trying to evaluate. So in the case of a quadratic, you can quickly evaluate it into its factors. In this case, the factors are 2 and 3, and we know this because when you multiply that out, you do indeed get minus 5x and plus 6. So integrating between 2 and 3, we see we're going to get a negative number because of the green shaded bit is below the x-axis. Remember, once again, that doesn't mean that the area is negative. We would take the area to be the absolute value of whatever value we get from integrating. So the left-hand side, we have integration 1, and we go step by step through how to evaluate each term. So x squared, as usual, add 1 to the power and then divide by the new power. You end up getting 1 over 3x cubed. And for minus 5x, x is to the power of 1. Add 1 to the power, divide by the new power, and you end up with minus 5 over 2x squared. And finally, 6 is just a constant. So technically, it's 6x to the power of 0. Adding 1 to that and then dividing by the new power is just 6x. In this case, we have our upper and lower bounds to be 3 and 2. And we just substitute that in as shown lines below. And it's evaluated to get minus 1 over 6. So yes, the answer we get is minus 1 over 6, right? But the area is positive always. So we'd just say that the area below the graph is 1 over 6. Now that that example is done, we thought we'd go and do a quiz. So I'm going to share my screen. Can people see that? Okay.
Yeah, we see that.
Is that working? Yep.
Okay.
So for those of you that haven't played Kahoot before, it's an online quiz, and we've just created our own quiz here. So please feel free to join www.kahoot.it, enter in this code here, and we'll just give you a minute or so to enter into the quiz, please.
Yeah, you can do it through the browser on your PC or use the app. Up to you.
One person in. It's a good sign. Expecting.
How many we're expecting? One, two. We're expecting 6
people. Okay, 2 more left.
Yeah.
One more user left. Hopefully they can join us.
Also, someone else new just joined. You're welcome to join the quiz as well. But we've went through the content already, so you might find it a bit hard.
I mean, feel free to join.
Yeah, feel free to
It's a
join.
little bit of fun, to be honest. And I'll go over every question and explain the reasoning. So I'll just give you I'll give you like 30 seconds, and then we'll assume that anyone that hasn't joined doesn't want to join, and that's okay. So I think it's 4 questions, so it's not long. And then, like Custard said earlier, after we complete the quiz, it's going to be a Q&A opened up to the audience, and you can ask pretty much any question you want related to maths or physics, and we'll try our best as uni students to answer your questions. Okay, let's see, has it been? Okay, so I think I'm going to start the quiz. I'll post Custard, do you mind posting the code onto the chat just in case anyone wants to join in late?
Yeah, sure. Yeah.
Then we'll start. Let me know once you're done.
All right. Yeah.
Okay, let's start. So yeah, maths integration part 1. Hopefully we'll have multiple parts to this integration class because it's a really broad topic, but I'll let you read the question. Is integration useful in finding? Okay, so we have 4 options here, and I'll quickly go over which one is which. So the correct answer is indeed area under the curve. The first point, gradient at a point, that's usually found through the inverse process of integration called differentiation. The y-intercept is found by finding the value of evaluating the function at x equals 0. The roots of a curve, so for those of you that haven't come across this term, the roots of a curve are the points at which it crosses the x-axis. So we saw in some of our quadratic curves that it crossed the x-axis at 2 different points. So we can say that that quadratic had 2 roots. But yes, indeed, the answer is area under the curve. Second question, which of these is not a polynomial? Think of this carefully. So I'm glad we caught out some people. So I'll go over why the other 3 answers are indeed polynomials. So in the case of the red option, so we had 2x squared minus 10x cubed all divided by x. So once you evaluate that, right, once you divide by x, you end up with just 2x minus 10x squared. And since both of those x terms are to the power of a positive value, we know that's a polynomial. In the case of the yellow one, which no one clicked, it's a pretty standard polynomial. We have a bunch of terms with respect to x, the power of a positive number. The one most people seem to have tripped up on is the blue option. So 5 is a polynomial, and that's because 5 is equivalent to 5 times x to the power of 0. Remember that key distinction where constants are polynomials purely because there's a, in air quotes, hidden x to the power of 0, which evaluates to 1. The reason that the fourth option is a polynomial, whereas isn't a polynomial, whereas the first option is because once you divide x squared minus 7x cubed by x cubed, you get 1 over x minus 7. See, the minus 7 bit is completely fine. That would be indeed a polynomial if it was just minus 7. But because we get x squared divided by x cubed to get x to the power of minus 1, that power isn't positive and whole. And as a result, the fourth option isn't a polynomial. To ask questions after the quiz is done, and we'll just go through them if things didn't make that much sense. So moving on to the next question. Equation. So I want you to work out this integral, and I've given you 4 options.
If you guys have forgotten the rule is add 1 to the power and divide by the new power.
Great. Okay, so we've got a nice spread of answers, which means I can explain why certain answers aren't correct. So in the case of the red answer, the problem with that one is there's 2 problems. So the first one is the answer hasn't increased the value of x to the 4. It's just divided by the power as opposed to adding 1 to the power, so it's x to 5 and then dividing by 5. And also it's forgotten the plus c. Remember, when we have an integral where we haven't defined what the upper and lower bounds are, we need to include a plus c so that we incorporate that lost information. The yellow option that no one clicked, that's incorrect because you're missing, you haven't integrated the 9 to become 9x. The green term is very sneaky because I've purposely left out the 3x to the 5 over 5, or otherwise it would have been correct. And then of course the blue term, the blue answer is correct because it's employing our rule of adding 1 to the power, dividing by the power, as well as adding making sure to include the plus c term. So we're going to go into the final question. Integral that you want to evaluate. Just think carefully about what the integral is. So it's x squared plus 5x minus 14 between minus 2 and 7. So this is the bit we're integrating.
I'll give you a hint. The answer should be quite simple. It doesn't require much calculation. All right, we have 10 seconds remaining for the final person. Oh, I think someone else joined because 5 answers is not everyone.
So, oh, that's a shame. Unfortunately, no one got that correct. Okay, so this one was a bit sneaky in terms of what we are trying to accomplish. So we saw the reason that the graph was given is so that you can see that the area that we're integrating over is below the graph. And as a result, once you evaluate that integral, whatever the answer is, it's going to be negative, right? And so because we're saying we're evaluating the function, we expect a negative answer. Area is positive, but once you evaluate the function, you get a negative result. And that's why Custard was saying it's you don't need much calculation because there's only one negative answer that we've given you. And indeed, that is the only correct answer, whereas the rest are all positive. And that would be the case if the quadratic was axis, but it isn't. Since the region which we are integrating is below the x-axis, we know that the area is going to be negative. I think that's the last question. Well done, Hai, for coming third. Robot Face is second, and then we have Carnage. Okay, so that's the end of the quiz. I'm going to stop sharing my screen.
Now we're just going to have a general Q&A where you can ask us anything, basically. So if
Feel free to ask us about integration or any other maths related or physics related question. If you have like homework that you haven't been able to do, feel free to like in your mic and please ask us the questions and we'll be very happy to help.
Alternatively, you can also just post it in the library chat if you don't want to speak. So.
Yeah, that's perfectly fine. So we do have a one question. Great. Feel free to just type in the chat. Yeah, that's perfectly fine. I guess technically you would be correct first. Fair enough. Yeah, no, that's well spotted. Yeah, thirst for carnage. I have two questions. Yeah, that's perfectly fine, Johnny. Thirst for carnage said technically because we said the values have to be positive and whole. Technically, I guess 0 wouldn't come under that, but indeed it does. I guess that was a carelessness in our phrasing. So it is indeed 0 and above, and it's only the integers or the natural numbers, I suppose. No, it would be the integers. Yeah, hopefully that clears that up. Question. These pictures are very small.
If you click on it, press show original, then.
Oh, fair.
Yeah.
These questions, it'd be better if after the stream is ended, I can send you the answer. I can like write up the answers for you, Johnny, 1, 2, 3, 4, and then I'll send them onto the chat. If that's okay. Yeah, no worries. I'll just after the stream is ended, rather than just have like a one-to-one conversation over a stream, I'll do the questions for you afterwards, and I can go through the answers with you. Well, ordering principle of mathematical induction. Interesting. So, do you know what the well ordering principle is?
No, we haven't come across that before. I searched it up, but there's this article on Brilliant that seems to be exactly what you are trying to find, I can send you the link. Yeah, so it has the proof. It's about halfway down the page, called equivalence with induction.
Circle theorem. Again, this one I'll do after the stream, if that's okay. For those that are curious in these questions and to find out, just stick around after the stream and I'll type in the chat with like my answers rather than trying to explain on the fly. Just send some worked answers. Well, yeah, we should be able to do these questions. No problem. Does anyone have any questions related to any of the integration points that we raised, or even like any other questions that you have like problems with? Feel free to like post it into the chat. Feel free to just post it into the chat.
So when you say implicit integration, you mean integrating with respect to x for something like y, right? That is something we're considering, but that's quite advanced integration. We'll probably want to go through kind of more general ones, such as integrating things like trigs and that sort of thing before we move on to kind of implicit integration, because that's quite advanced.
Yeah, so like typically like I guess in this case implicit integration is referring to integration where there's multiple variables. So where we had just x, in this case it could be x, y, and maybe z. Those concepts are usually taught in like first term of an undergrad course, which probably is a bit too far for the courses we're trying to aim at, especially with integration being so broad. I think it would take a lot of courses before we get to that in particular. That's a good question. Any other final questions? Feel free to just type it into the chat if you do. No worries. It's our pleasure. Okay, so I think that might be the end of the lecture / stream. Custard, unless you want to say something, I think.
Yeah, unless there's any more questions, I think we're gonna wrap this up for now. But yeah, thank you guys for coming.
Thank you.